So example 2, because again, like I said, yesterday was example 1 on the video notes on standard deviation. Example 2 is we're going to use the same data from the warm-up. Okay? So let me get your ages here. Let me copy and paste this puppy. Here's your ages. Let me copy and paste. Okay? All right, here's your ages. Mr. Munguia's 4th period stats class ages. All right. The first thing I want you to notice is this formula that looks very scary. Okay? It looks a lot scarier than it actually is. And I kind of mentioned that on the video, I think, yesterday that you were watching. You have the square root, okay, of a bunch of stuff underneath the square root. A lot of stuff is going on. Notice what's going on underneath the square root. Let me use red to kind of focus on what's going on. What's going on is I'm taking every data value. That's what x sub 1 means, x sub 2. Look at x sub n. What it means is every data value from the first data value to the last. Talk to me. After this, hang tight. I got you. You too? Oh, you have to be raising your hand. My bad. So look what's going on. I'm taking every data value and I'm figuring out how far every data value is. Okay, well, it goes dot, 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 dot to the last data value. That's what the x sub n, x sub 2, x sub 1 means. I'm taking every data value and I'm figuring out how far away is it from the center, the average. Look at x bar, x bar, x bar. How far is every data value away from the center, the average? Remember, the center and the average all mean the same thing. It's x bar. How far is every data value from the x bar? In other words, how far is Ontiveros from the average? How far is Gabriel from the average? Rojas, all you. How far is every single one of you away from 16? That's what we're doing right here in this numerator. And not only are we doing that, we're adding them up. All those differences. And then we're going to divide by how many students there are. The n represents how many data values there are, kind of like when we find the average. And then we take the square root of the whole shemek. It's not that big of a deal, this formula. It looks harder than it actually is. And the thing is, these 5 steps are actually doing this. They just kind of make it into bite-sized pieces. And last but not least, there's a Greek symbol, a Greek letter. I think I mentioned in the video yesterday, sigma. It's like a 0 with a little tail. It's from the Greek alphabet. Greek was a high academic language back in the ancient times. The Bible was written in Greek, the New Testament. And a lot of academics and scholarly works were done in the Greek language. Very special language. So whenever we find standard deviation, sigma is the variable we use to represent standard deviation. We're only going to do one example and we're done with our notes. Just one. Okay, here we go. Here we go. Step 1. Find the mean. Didn't we do that for warm-up? Step 1's done. X bar is 16, you guys. I mean, if you're paying attention, right? We did that for warm-up. So step 1's done. Wow. Step 2, find the deviation. To deviate means to stray away from. Find the deviation of each data value from the mean. In other words, how far does every single one of you, your ages, how far away does each one of you deviate from the average? How far does Mr. Gabriel's age deviate from the average? How far does Rojas deviate, that means stray away from the average? Valencia's age, stray away from the average. Well, we're going to take every single one of your ages and subtract it by 16. That's it. Here we go. We're going to use a table to kind of facilitate and to help us get through it. Watch. Make a table with 3 columns. All the way right now for the R snap. Unless you don't care about R snap, that's fine. Stupid games win stupid prizes. Data, think the best. Deviations, and then squared deviations. Okay, so far so good. We're only going to do one example. All right, what's my data? Well, it's right here. I'm going to put them in order from least to greatest. You don't have to do that, but I'm going to do it for us, for our sake. So let's see, I'm going to go, there's 2 15-year-olds in here, Fonseca and Gabriel. There's 4 16-year-olds in here. You know who you are. And there's 1 17 and 2 18-year-olds. So I'm going to see how far away every single one of you deviates from the mean. The average age in here is 16. How far does each one of you deviate from the average? Well, I'm going to subtract. Watch. How far does Fonseca deviate from the average? I'm going to subtract the 2. How far does Mr. Gabriel deviate from the average? I'm going to subtract the 2. How far does Quintero, you're 16, right?
Yeah.
How far does Quintero stray away from the average? Whoever else is 16, the second student who's 16, how far are they away from the average? Third student. Fourth student who's 16, how far away are they from the average? The 17-year-old, Valencia, were you 17? Who's 17? Martinez. How far does she stray away from the average? And Ontiveros, how far is he away from the average? And I forgot the other 18-year-old in here. How far is that other 18-year-old stray away from the average? Now again, when I say the word stray, I mean deviate. Did my coffee didn't kick in or something, or what? What's the matter with me? Don't answer that. It's a joke. Thanks for laughing. Appreciate it. All right. 2, 4, 6. All right. Sometimes in you may have heard people display, they'll call it deviant behavior. Deviant behavior means abnormal. You're stray away from normal behavior. Like let's see, on my way home I saw a homeless man. He was sleeping on the sidewalk, and he was using a rock for a pillow. That's like deviant. That's deviant behavior. Typically, people are laying down in their house if they're going to take a nap. He's right there on the curb. So that's deviant. So deviate means to stray away from normal. In this class, the normal age is what? 16. So right now, I'm figuring out how far away each one of you stray away from the average. That's deviations. Here we go. 15 minus 16 is a -1 if my coffee is kicked in. -1, 0. Look at the 16-year-olds in here are right on the normal, so they don't stray away from the normal at all, because they're exactly the normal age. The 4 16-year-olds in here. The 17-year-old strays away from 1, and the 18-year-old strays away from the 2 years. There's your deviations. That's not that hard, you guys. Come on. Let's not overthink this. Let's square those puppies now. The third column says squared deviations. In other words, take every single one of these values, every single one of these, and square that puppy. Square them all. Take them to the second power. What was that all about? You with me, Fonseca? Okay. Everyone's writing, but you're not, so that's what I'm asking. You're the man. What's -1 times -1, Fonseca? Woo! Negative times negative is positive. 0 times 0 is 0. All these are zeros. 1 times 1 is 1. 2 times 2 is 4. Nice. This lesson is just really how good are you with directions. It's not like high level math we're doing here. It's just, can you follow the dang directions? That's it. It's really what this is measuring. It's not highfalutin math here, you guys. There's a lot of steps. So let me go back to 5 steps. We squared each deviation. We just did that right now. So step 2 is the second column. Step 2 was right here. We found the deviations. This is step 2 right here. Here's step 3. You see, all I'm doing is just breaking it down into bite-sized pieces, that whole nasty formula. In other words, look at we've done this with the middle column. We found the deviations. We've just squared them, right? That's what we're doing. We just squared all the deviations. We took the result of the deviation and squared them. And now look at, we see some pluses. We're gonna add all those puppies up. We're gonna add the squared deviations. That's step 4. We're gonna find the mean of the squared deviation. That means add them up, divide by how many there are. That's why we look at the formula, we divide by n. N here means how many data values there are. So we're gonna add them up and divide by n. Not a big deal, guys. Come on. 1 plus 1 is 2, plus 1 is 3, plus 4 is 7. Wow. This is a hard class, Mr. Munguia. That's step 4. This is called the variance, by the way. So on your notes, when you add up those square deviations, go ahead and put an arrow there and write variance. That's just a vocabulary word you need to know. The variance. When you add up those square deviations, we're talking about the variance. Almost done. We're on the last step and we're done with our notes. You guys are doing awesome, I must say. Step 5. Look at, take the square root of the variance, which is why that nasty, nasty formula has a square root. I'm going to square root the whole shemak. This is all, look at, I've added all the deviation square on top for the numerator. I'm dividing now by n. You know what? 7 is not the variance. I forgot to divide by n. Forgive me. I forgot to divide by how many students there are. Forgive me. That's the variance. 2, 4, 6, 8. So 7 divided by 8. Sorry about that. Coffee time again. 7 divided by 8 is the variance. I'm going to round the nearest whole number. 0.875. 0.875. So I'm going to round it to the nearest whole number of 1. So the variance is 1. So approximately 1. Because the whole number is a 0. I looked around, it's 5 or bigger, it's almost at 1. So let's just run this whole number. This is the variance, my bad. Forgive me. Cruz, you with me? What's the last step, Cruz? What does it say for step 5?
Take the square root of the variance.
There it is. I'm going to take the square root of 1. And notice, sigma, the standard deviation, is the square root of 1. It's the square root of 1. 1 number times itself becomes 1. 1. Standard deviation then is 1. You don't believe me? Type that up in the calculator. Now what does this mean now? Check this out. We did all this gymnastics, this arithmetic gymnastics, all these steps, and we got this number 1. Now what the heck does that mean? What does 1 mean? So what? We got 1. Now what, Mugia? What does that mean? Here's what it means. Watch this. This is the key here. You gotta know what it means. 1 means the average distance between each student and the mean age is 1. The average distance between each student and the mean age, the average age, is 1. So it tells a researcher or someone who's studying this class, that person who's studying this class said, you know what? Most of the kids in this room are about 1 year away from the average of 16. They're about 1 year away from the average. That's the average distance for each student from the center of the students. So it gives an idea of how spread out the data is. The bigger the standard deviation, the bigger this number, that tells a scientist the data is more spread out. The smaller that number, that tells a scientist, the data is more compact. And it is. Look at 1. That's a small number. That means you guys are kind of closely packed together in terms of age. Youngest is 15, oldest is 18. You guys are pretty close together. That's what that number means. The average distance between each student and the mean age is 1. 1 year. Go ahead and try the Jamboard on your own.